Viewed in its raw state, the world is a chaotic cloud of unreadable data points. Turning noise into clarity requires a specific structural alignment. This is the function of research. It is a systematic, critical investigation into a phenomenon designed to extract signal from the static. To find that signal, we construct a research pipeline, a strict 7-step dependency chain where every link relies on the integrity of the prior one. Methodology is an engineering problem. If the foundation is flawed, statistical conclusions will inevitably collapse. We begin with step 1, research design. This is the blueprint for the entire project, defining the scope and intent of the inquiry. Descriptive research focuses on establishing the facts of what is currently happening. Exploratory research looks deeper to discover the underlying causes, the why behind the observations. And experimental research employs controlled methods to isolate strict causal relationships. This blueprint determines step 2, the raw materials we use, which are classified as either qualitative or quantitative data. Qualitative data is rich and subjective, relying on words and descriptions. It provides depth, but it is resistant to mathematical manipulation. Quantitative data, however, translates observations into calculable units. This numerical transition makes a specific suite of mathematical operations possible. By assigning values to variables, researchers can calculate exact percentiles and determine the frequency of occurrences across a population. The choice between words and numbers at this stage determines the limits of the statistical tools available at the end of the pipeline. This leads to step 3, measurement and scaling. This Noir hierarchy acts as a bottleneck. As you move up the tiers, more powerful mathematical operators become available for analysis. At the base is the nominal scale. These are pure labels, where the only valid operation is counting the frequency of each category. The ordinal scale introduces rank order. It measures relative magnitude, enabling the calculation of the median and the mode. For example, look at question 117. Even a subjective opinion about the relative beauty of two people is treated as ordinal data because it forces a ranked comparison. The interval scale provides equal distances between each point, but lacks a true starting point. At the peak, the ratio scale includes an absolute 0. This tier allows for every possible statistical technique, including the calculation of coefficients of variation. Climbing the NOIR pyramid equips the researcher with the mathematical precision required for advanced downstream analysis. Step 4, sampling strategies. Research usually operates on the reality of incomplete information, where we must draw conclusions about the whole from a small fraction. A census measures the entire population to find a true parameter. A sample measures a subset to calculate a statistic. Questions 6 and 7 in the source material highlight this trade-off. Surveying all 954 customers is a census. Selecting only 100 of them is a sample. Because a total census is often impossible, researchers must define a sampling frame, the specific list from which the subjects are drawn. Probability sampling, such as stratified random sampling, ensures the sample's proportions match those of the population exactly. In contrast, non-probability methods like snowball or convenience sampling select participants based on their immediate availability or referrals. Sampling always introduces error, but probability-based methods allow researchers to mathematically quantify the level of uncertainty in their final findings. We move to step 5, data collection methods, the actual extraction of information from the environment. Information comes from primary sources involving direct interaction or secondary sources, which utilize archived and published documents. One primary qualitative tool is the focus group. A moderator maneuvers a structured discussion to reveal how a specific group perceives a topic. For maximum reliability, an ideal focus group consists of 8 to 12 members who are strangers to one another, preventing existing social dynamics from biasing the results. Quantitative collection typically uses the questionnaire. This instrument requires clear-cut, self-explanatory questions to ensure the data is accurate. A common point of failure is the double-barreled question, one that asks about 2 different issues but allows only one answer. This effectively corrupts the data. A poorly designed collection instrument introduces noise that can't be filtered out, making all subsequent analysis invalid. This brings us to step 6, hypothesis testing. A research hypothesis predicts a relationship between variables, stated so it can be strictly confirmed or refuted. The testing process splits into two distinct mathematical paths, parametric and non-parametric. Parametric tests are based on strict assumptions. They require interval or ratio data and a normally distributed population. If the population variance is unknown or the data is only nominal or ordinal, the parametric path is excluded. The researcher must then use non-parametric or distribution-free statistics. These provide valid results even when population assumptions are not met. This involves specific tools like the Mann-Whitney U-test for independent samples, the Wilcoxon test for related samples, or the Kruskal-Wallis test for multiple groups. The choice of statistical test is not arbitrary. It is a direct consequence of measurement and sampling decisions made at the start of the pipeline. We reach the end of the chain with Step 7, the final report. This requires a full bibliography and proof of ethics clearance, steps that ensure the study is both transparent and replicable. These components allow other researchers to audit the findings and study the problem from different perspectives. Looking back, every step in the pipeline, from design to data type to measurement level, is interconnected. Rigorous research relies on an unbroken chain of logic, where every step acts as a load-bearing pillar to guarantee the truth of the final conclusion.